Hello, welcome. This video is to talk about key software code quality factors. Let's get started. Why code quality is important? Bad quality software is usually more expensive to maintain, adapt, and evolve. A study discovered that global economy loses around $3 trillion every year due to malfunctions caused by defective software. Martin Fowler quoted, "Any fool can write code that a computer can understand. Good programmers write code that humans can understand." Yes, writing a good quality code is extremely important. Any software ultimately is meant to serve a purpose. If the code doesn't fulfill the needs for which it was originally designed, then it cannot be considered good. Here are the top software quality aspects that should always be remembered: maintainability, testability, scalability, functionality, reusability and modularity, performance and efficiency, portability. Some of them may look like software design aspects, but they need to be considered during development as well. We will see these quality factors in detail. Maintainability. Maintainability refers to the ability of software to modify without damaging current system. Any software should be easier to read, flexible to modify it for fixing bugs, adding, enhancing or removing features. As Martin Fowler said, anyone can write a working code, but it may not be a good code. Maintainability makes the real difference between the working code and great code. Maintainability has other closely related terms such as flexibility, extensibility, readability. Flexibility is how easy to do any sort of modification in the code. Extensibility is how easily the new features can be added. Readability, the ease with which another developer understands a piece of code. Testability. Testability refers to the ease with which a software can be tested. Any good software should ease the test process and provide more support for test automation. There is no doubt that well-structured code would definitely improve the testability. High testability results more better tests. Lower testability means fewer weaker tests. Scalability. Scalability is the ability of a software to continue to function well even when the load increases. Of course, scalability cannot be usually achieved without adding more hardware resources. But the same code should continue to work well with increased hardware resources. So there are two scalability strategies exist: scale up and scale out. Scale up involves increasing system resources such as processors, memory, disk, network adapters, so on and so forth, to the existing hardware, or replacing the existing hardware with greater system resources. Scale out involves adding new servers called nodes to meet demands in distributed environment. Functionality. Functionality is the ability of a software to carry out the functions as desired. Beautiful, readable, testable, maintainable code that fails to meet the business needs is still a failure, right? All these quality factors are not meaningful when we are talking about unfunctional software. So what we have to do? First, perform desired functionality and produce correct software. Then apply quality factors on it. If you can perform both in parallel, that will be the best. There are some sub-factors that need to be considered to achieve the complete functionality. They are security, interoperability, compatibility. Security is protection of software against unauthorized access, privacy attack, theft, loss of data, so on and so forth. This may include authorization and authentication techniques, network attack protections, data encryption, and so on. So while developing, all possible types of security leaks should be considered. What is interoperability? It refers the extent to which system can exchange data and interpret the data that it received from other system. For two systems to be interoperable, they must be able to exchange data and subsequently present that data such that it can be understood by a user. Compatibility is the suitability of software for use in different environments like different operating systems, browsers, so on and so forth. Reusability and modularity. Reusability refers the ability to reuse the existing software code and its components. Code reuse aims to save time, resources, and reduce redundancy. Modularity refers breaking a code into modules in order to keep everything concise and easier to debug reuse. Code reusability depends on modularity. Performance and efficiency. Performance is mostly about response time of the software. Code should be optimized to execute more quickly. The code also should be capable of running with less memory processor footprints. The choice of algorithms and data structures affects efficiency more than any other aspect of the program. Normally, performance is validated by testing the scalability and reliability of the hardware. Portability. Portability is a measure of how easily an application can be transferred from one computer environment to another without requiring major rework. The phrase to port means to modify software and make it adaptable to work on a different computer system. In order to write a high quality code, these quality factors should always be remembered. Thank you for watching.